that is TA session, TA revision session. I think that is TA revision session possibly, but not this one. Okay, just give me a minute. Huh?
Okay, sir.
Okay, I hope my screen is visible to you.
Yes, sir.
Okay, so I think we should start the session. For that, okay, anybody like who has joined and now because of the delay has left session? No, right? You guys are there. Okay, maybe you didn't notice. Fine. So this week 5 is what is about uh, linear regression. Is that fine? So I think we have seen the probabilistic view of the linear regression as well as what is the basic uh, loss function here we are using in linear regression. Loss function or cost function, whatever you can call it. What is it? Which loss
Mm,
function we use?
least square.
Least square. Okay, and we have seen by using the probabilistic approach as well that this least square, uh, when we say that we are using least square approach for linear regression, in that case we are assuming that the labels are generated uh, by assuming there is a noise which is normally distributed, right, or Gaussian distribution is there. Okay, fine. So now this is the question for you. Suppose you are given three training instances, x1, y1. What is x1 here?
Data point.
I think x1, y1 is the data point, right? Okay, so these
Okay.
are the features, right? X1 is the feature, y1 is the corresponding label. So x1 a y1, x2 y2, and x3 y3. This is entire data set, uh, and we have given all those values, right? So x1 is in how many dimensions in this case? By looking at this
Two
data, it is in
dimensions.
two dimensions, right? Okay, so where each xi is a data point and y is a corresponding label, your goal is to predict the output y hat based on the features where y hat is x transpose w hat. Okay, w hat is w1, w2. Find the w hat that minimizes this squared error loss where y is equals to 110, and that is visible from the dataset itself. Okay, and this is the question. So what do you need to find out here? W hat, which minimizes the loss, and we know in linear regression what is the W star we get. The minimum value of W is what? W star is
X transpose pseudo inverse X into Y.
Y. Okay, and I think this is not pseudo inverse when we use when your matrix is non-singular. Sorry, singular. I think this matrix is singular, so you can use inverse instead of pseudo inverse. Fine. Okay. Now we can solve it. Take some like maybe 2 or 3 minutes to solve, and then we can discuss the solution.
I'm audible?
Yes, yes, yes. You're audible.
I think presentation stopped, no? Presentation stopped
Present.
or
Yeah,
something.
yeah. So this question is, I didn't. I'm not moving it, right? Let's call this question.
Okay.
Uh,
Okay. I'll run it. Sorry.
okay. So I think few of you have answered it. One by three, one by three, minus four, minus five. So Sushmita, Mustafa has given minus four, minus five. Sushmita has given one by three, one by three. Riti is one by three, minus two by three. Okay, I think Mustafa has changed the answer. Four by
So
five.
can you please speak a bit loudly? I'm not able to hear you.
Is it? I'm actually speaking loudly, but I don't know. Okay. Maybe.
Okay.
Yeah, I am listening little bit slow voice.
Is it? Now is it fine? Uh,
It's very low volume. I've increased my volume, but still it's coming low.
One minute. Then I don't know any issues in the. Okay. Is it still? Is it fine? Now is it fine if I speak loudly?
Yes,
Then?
sir. No, sir.
Okay, I'll try to speak loudly then. Okay. So I think okay. Mustafa has changed the answer, and I think these are the answers, right? So one, two, three, four, and five. Five people have answered. Okay, fine. So let us see the solution then. This is like same problem. The answer to this problem is what? Xx transpose pseudo inverse, or let's say Xx transpose inverse into xy, right? Or Xx transpose inverse xy. So what is x here? The matrix, right? Which matrix it should be? It's 1 0 0 1 1 1. Is that fine?
Yes, sir.
Is that correct? That will be your 2 cross 3 matrix. That is your x matrix. Y is what? 1 1 0, and then X transpose will be the transpose of that. So X is this matrix 1 0 0 1 1 1, and the label vector is 1 1 0. So first of all, what you will have to do is you will have to calculate X transpose, and that will be a 2 cross 2 matrix, because your X is 2 by 3 matrix, X transpose is 3 by 2 matrix, and if you multiply that, you will get a 2 by 2 matrix. So it is 2 1 1 2. Now if you wanted to find out the inverse of that matrix, so that inverse will be 1 by 3, 2 minus 1 minus 1 2. I hope all of you know how to find out the inverse of the matrix, right?
Yes.
Yes, sir.
Okay, and this is the solution to the linear regression problem, right? We have seen the derivation for it, and I think that is your solution. Then it's like a simple thing. You'll have to do the multiplication. So this matrix inverse into x into y, and then you'll get this 1 by 3, 1 by 3 as the answer. So the correct answer is 1 by 3, 1 by 3. So W1 is 1 by 3, W2 is 1 by 3, right? Okay. So the next question is for the data set given below. So this is the data set. It is a D cross N matrix, but uh, you can see, right. What are the number of features here? Two dimension, two, right? Two features, and how many examples are there? Four
4.
examples. So that is why your X matrix will look like 2 by 4 matrix. And if you have four example, that means you will have four corresponding labels, right? That is why y is a 4 by 1 vector, right? Okay. Or then initialize w naught with 0 0. The learning rate is 0.01. Let gd be the updated weight vector after one iteration of gradient descent, and wsgd be the updated weight vector after full iteration, by taking first two and the next two data points for the sample. Okay, now you'll have to. What is this? This is a stochastic gradient descent problem. So initially, what you'll have to do, you have to consider only these two uh, data points first, and then later two, right? Data points. Fine, and then you'll have to find out this WGD minus WSGD. Okay, sorry. I think I'm just missing it. So I think this is only a gradient descent problem, right? GD is gradient descent problem. You will have to use all the data. Is that correct? For one iteration. And
Yes.
WSGD is the stochastic gradient descent. You will have to use for the first step. You'll have to use two samples, and for the next step, you'll have to use two samples, and then you'll have to take the average of that, right? Then you'll get WSGD, and you'll have to find out the length of the difference between these two vectors, right? One vector is WG, the gradient descent vector, and one is uh, if you whatever the updated weight vector you get from the stochastic gradient descent. Okay, and this is the loss function you'll have to use. I hope you understood the problem. If any doubts are there in the problem, you just let me know. If not, then you can start solving this problem. First of all, calculate W gradient descent problem, and then go to the stochastic gradient descent. Yes, Sushmita. Yeah.
Sir, am I audible?
Yeah.
Sir, my question is not related to this one. My question is related to the exam.
Ah,
That similar to Stat 2, will formulas be provided in MLT as well?
MLT, we don't provide formulas. So if required, right? Uh, like if let's say W hat, right, which is X transpose inverse XY.
Yes.
If where it shows like this, we'll be providing you the formulas, but not for everything. So like let's say you need it for W star, right? That will be provided to you. If the formula is too complex, it will be provided. Otherwise, the separate sheet will not be there. Formula sheet.
Okay, sir. Thank you, sir.
Yeah. I hope all of you know that quiz one syllabus is week 1 to 5, right?
Yes,
Yes.
sir.
Yes, yes.
Okay. Yeah.
Sir, what is the meaning of the line updated to it after one full iteration of stochastic gradient descent by taking first two and then next two data point?
So what is stochastic gradient descent? You do it like batch wise, right? Kind of.
Uh,
So you take a
yes, sir.
first batch and apply the
Okay,
gradient descent over that batch. Okay.
okay,
and
okay,
and then the second step. So let's say there are now in this case we have only two steps, right? So small t
okay,
equals to 1 and 2. So in the first step uh, you take only two samples, apply the gradient descent over that sample. In the second step
okay,
you take another two, and then take an average of both.
okay, okay, okay. Understood, sir.
Got it, right? Yeah. Yes, Disha. Yeah.
So for first one, we have to do the formula that we did in Amal.
Yes, yes, similar. Like because what you have to do, right? It's just like simple gradient descent. Like Wt plus one equals to Wt minus eta del of f of w, right?
So W not
The
W plus neta X transpose Y.
so okay, in general gradient descent is what? It's the descent, right? So Wt plus one equals to Wt minus eta del f of w. But what is del f of w here? So what is the function here? F of w, that is your uh, squared error loss, right? And then you take the gradient of it with respect to w. I hope you remember that formula. Do you have notes with you? The class notes, lecture notes.
Yes, sir.
The formula is there for that. Okay. If you can see those, you can see that. Uh, Maybe you can see that formula. Okay, I'll show you from here. This formula you should use for gradient descent. X is transpose W naught minus XY.
Okay.
So for the SGD, both the initial ones will be 0, 0 only.
Yeah, yeah, initiation. Okay, for no, no, I think it shouldn't be like that. So this is the formula, right? This is first step, and the second step you'll have to use the first one. So
Okay.
whatever you have got in the first step, you'll have to use that in the second step. So
Okay.
what is the difference between the gradient descent and the SGD is that gradient descent you take whole data, right? And you do perform the iteration, and then in the next iteration what you take the whatever we have updated weight vector in the previous iteration. In the stochastic gradient descent, the process is same. The only thing is in one iteration you do like multiple iterations, right? uh, I hope what I'm trying to say is understandable. Let us say, because you have, let's say, 100 data points, right? You take 2020 batch, so you do it for 5 batches. So whatever the first batch updated vector is there, you use it for the second, and then you use it for the third, like that, and you will finish the entire batch. Again, whatever the entire batch gradient descent is there, you use for the next one. So it's kind of mini gradient descent within a gradient descent. It's kind of like that.
So, but in the lectures, I don't think he has mentioned that for the initial, this for the second one, you have to take the previous one like that.
Yes, it is not mentioned explicitly, but yeah, it is like that. Or you can do one thing is, I think that also is a approach, right? I think you can take an average of all. So you take one, you take another, and like that. But it will become like you're not iterating that, right? Iteration will not be there. You take separate gradient descents, and you take the average, so you'll get a small direction. Correct, right?
So do we have to take 0, 0 only, or how do we have
No,
to
no.
proceed?
Take the first, whatever we have got in the first. You should take
Mhm.
for the second.
Okay. Okay.
Okay, yeah, because that's how the solution is prepared. But I think the other way is also not an issue. But what you will do, you understand, right? Each let's say if you take the smaller batch, you will get some direction, right? Updated vector into some direction. Then for the second batch, you will get some other direction. And like, let's say you have 100 data points, you have like you can have the 5 different directions. What you take, you add all these 5 directions and take an average of it, you will get one direction, and then you will move into that direction. That is the approach actually sir has told, right, in the lectures. Is that correct, what I'm trying to say? That also is fine, but you can do this way also. Like, you take first whatever the updated vector is there, you just use that one to get the second one. So that way you don't need to take average. uh,
Okay. So if we do it individually separately, then we need to take the average. If we
Average,
take,
yes,
yeah.
yes.
Okay.
And if you don't want to take that, then because both the things are same, right? At the end it is same,
Right.
right?
Right. Right.
So that is what we, because we wanted a direction in the uh, like like if you take the entire batch of the data points, the same direction we wanted to go. But if you take the samples of the data, then we might not end up into the same direction, but we wanted to go as close possible as a gradient descent, normal gradient descent. Yeah, you are able to picture it, right? Imagine the picture, right? So all the directions and all, are you able to picturize that? Okay, maybe after some time, maybe I'll show you. I'll draw that in.
Sir, I want to say something.
Yes, yes.
Suppose, sir, for that stochastic gradient descent,
Okay.
if I am considering W naught as 0, 0,
Hmm.
and I'm getting something as a W1,
Hmm.
for W2, I'm considering that W1.
Okay.
Say I'm getting 0.08 and 0.07.
Okay.
I'm getting W2 SGD, and first I have W1 SGD when I've considered 0, 0. So
Okay.
in that case, won't I will be means do I need to find that average for both?
No,
both?
not now. No, in that case we don't need to, right? Because you already have used the updated one, so you don't need to take average. When you
Oh,
need to take average is, initially you took 0, 0, you found
hmm.
out W1. Okay. Then
Yes,
for
sir.
the second batch or second sample,
Hmm.
you again took 0, 0, and you found out one direction.
Then only we need to take that.
Then you right, because when you in this approach, when you take one, like let's say 0, 0, and you found out W1, let's say, and now you are using that W1 for the second batch or second sample. Now you are already using the information which is given by my previous sample, right? So now I don't need to do that.
Oh,
Is
then
that fine?
I actually thought that for W1 we are getting one direction. When we are doing it for W2, we are getting some other direction, and then I need to take the average. So I chose that.
Yeah, but that you should do when you take 0, 0 initialization for both. So if you take the same initialization for both of them, right, or like whatever the batches you are having, in that case you take average.
Okay, then maybe my answer is wrong. I posted in there.
Then you don't need to worry about it. No, you have taken the average, remove that average, and
Ah,
whatever the answer is there, that should be your answer
okay,
before
sir.
before averaging that one, the final
Since
one.
there are multiple ways of doing it,
Yeah.
is there any preferred way that will be used in case of a numerical? When
Uh,
it comes to algorithm using the standard packages, that obviously we don't have to bother about it.
yeah.
Just to test our understanding, if you are going to ask questions on numericals,
Yeah.
should we go through?
I think both of the strategies which we have used now, I
Yeah.
think both of them will give the same answer if you try it out. If you
Harish,
yeah, you just check out
maybe smaller examples. Okay, we'll check it out.
with the same this example only you can check it out, no? Like take initialization 0 0 for both the batches and
Okay.
find out the vector, and like by averaging it, and this anyway we already have this answer, right? So we can cross check like whether it will get the same answer or not. uh, as per my understanding it should get, like you should get the same answer, because we are using the previous vector like to get the next one. But let's see. I'm not sure about like whether you should get, or either we should be in the like nearly we our answer should be as near as possible as the previous one. But both of the things are not wrong anyway. Both are is fine. Both approaches are fine. So shall we check the answer for this problem? Anybody?
Sir, 1 minute.
Okay, okay, okay. If you are solving, then I'll go to.
Where are these questions available?
I think they are available from the previous batch also. But if it is not, we'll update all this
I saw
to
that.
the
Oh,
supplementary contents.
okay.
Yeah. Anyway, we are uploading that to supplementary content, so you can take it from there.
Sir, if we take average or not, we are getting the same answer.
Same answer, right?
Yes, sir. I think.
That is what I was saying. That. Okay, is it done now? Shall we check? Please submit. If you guys have answered 0.074. Okay. That is the final answer you said, right? Like the length of the this difference.
Yes, sir.
Okay.
It's in a range because once I used the average, I deleted the average part. It's 0.073 kind of.
Okay.
I guess it's a range. Yeah.
Anybody is trying, or shall we see the solution?
Done, sir.
Done. Okay, so as mentioned previously, so WGD should be W naught minus eta, and this is what is del f of W, right? The partial derivative of the function of that W. And if you see the calculations here, so XX transpose is here, W naught is 0 0 because you started with initialization as 0 0, and this is XY. So you should get 0.23 and 0.20 as W1 and W2 in the gradient descent, right? After one iteration. In stochastic gradient descent, we need to use only first two data points in the first step, right? In the first iteration of first step. In that case, it should be this, right? So batch one, x of batch one, we'll have to use, and accordingly, so that means you should use only these 2 points, 1 2 2 1, and after using that, you can see the solution, and it should be 0.08 and 0.07. So if you use this updated vector for the next one, you don't need to find out the average of the second batch and the first batch, right? Whatever the updated weight vector is there. But if you're not, then you can use the previous one, which is here 0. So if you see the calculations here, we have used w naught as 0, right here, and in this second step we are using 0.08 and 0.07, which is the updated weight vector uh, after the first batch, right? Like the first two data samples, and and by using that, we have found out this as the weight vector. So this is like after completing entire sample or entire data set, we are here as 0.1932 and 0.1632. And if you take the, I think, okay, if you're taking the average, it will, okay, I think there is some mistake in here. uh, mm, we shouldn't take the average here, right? Okay, I think we should not take the average here once you found out the answer. Okay, no issues. Let us see. Then we have found out this, and this should be the answer, right? So how? So somebody has calculated this by using without average. What was the answer for you?
Yes, sir, it's 0.074. And for
Without,
W2, we are getting 0.15 and 0.13.
okay, and that time you didn't take the average, right?
And no, I took the average because I used then 0, 0 for
Both,
W1. Yeah.
both calculations.
Yeah, both calculation. First one is giving 0.074 and second one is giving 0.073.
Okay, fine. Okay. So you just check it. I think I will also confirm you with you like what should we use here.
So
But yeah,
WSGD, what is the value, sir? This is okay,
it is
0.1366.
right.
And if you consider 0, 0, then this value is 0.115 and 0.1.
0.1.
Yeah, that is what I'm getting, but I'm not getting the final.
Yeah, the final for you need to subtract it with
Subtract.
W20.
We'll have to subtract.
Yeah, 0.23. Yeah, okay.
No.
Yeah, right.
Fine, right? Okay. Anyway, this calculations are with you. Like I will anyway upload this to the supplementary content section. You can find out answers from there. So
So, sir, finally we have to take the average or no need to take?
so I think, see, anyway I'll confirm with you. But
Okay.
let's say if you use this 0, 0 here, right? My thinking is if you use 0, 0 in both the cases, right? Let's say here we have used 0, 0, right? Initialization, and if you use 0, 0 here also, then you need to take average, otherwise you shouldn't take the average. That is my,
So here they have combined both the ways.
yeah, but I think it shouldn't be like that. Okay, next session, whenever I'll take session, right, that time I'll confirm with you. Fine.
Okay.
Because see, then what is the point, right? You have used the previous one to calculate the next one, and now you're taking again the average of it, right?
But we are not seeing any difference, not much difference between combining both the ways and using one by one, no?
Ye- like,
As per
actually it
Sushmita.
depends on, so this data set is like that, let's say. If it is
Okay.
not, then what will happen, right? I'll confirm with you. Fine.
Okay.
the
Okay.
the proper method which we should use, I'll, in both approaches I'll let you know. Okay.
Okay.
Okay, so the next question is, consider the following data points for a regression problem. C1 is some real number, and okay, so, and U is in D dimensions. Fit a linear regression model for this data set and find a predicted value for the test point 5 times U. Cy and Yi is 20, and okay, so Okay, what is U here?
Data set, is it?
Or maybe you can send, the data points which are in d dimensions, let's say.
So,
And
but the C is the W, is it? The unknown parameter, is it?
uh, I think it is not an unknown parameter, but it looks like here, right? Some constant. You can think of some constant, right? But for each of this U, the multiplication is different, right? So what will happen? Let's say U is some vector, right? And you multiply that vector with some quantity. So it will get elongated or contracted, right? So for each of all, I think U is same.
Is it a linear combination?
Yeah, you can see, right? Because everything U here is same, right? Across the data points. The only thing is they, so what you can think about from here is, I think all the data points are on the same line. Is that fine?
Okay, sir. So C1 is just a constant.
Constant,
Okay.
yeah. See here,
Okay.
it's some real number, and C1, C2, C3, they might be different. Okay, but U is same. So what you can see is, U is, let's say U is some vector in d dimensions. What you are doing here is, you are just multiplying with some constant, and now you are getting the, for the data point you are saying that y1 is label. Let's say C1U is one data point, you are saying that y1 is the corresponding label.
So it is a weighted average, no? Some weights we are giving.
uh, yes, we are like weighting that vector, and you're saying that, okay, the labels are there for that corresponding thing. So uh, if you understand it in a way that all these data points actually lie on the same line, right? Or same hyperplane, possibly. Is that correct? But uh, they all the data points are on the same line. That is that fine for you? Like that understanding is there?
But the extensions are like shrinkage or
Yeah, or expanded.
expansion depends on C1 to Cn.
Correct. Right, because they all are the real numbers. And now what you have to find out, you have to find out the prediction for y, which is 5 times u for the data point x time exist. I think this is the simple one to but yeah, just find it out. So you will have to use that loss function definition. So what is loss function for linear regression? It is summation of I equals to 1 to n w transpose xi minus yi whole square, right? You will have to use that and the gradient.
Sir, in exam, how to figure out that we have to use the loss function here? Is there any clue in the question?
No, mostly what is asked here in this question, to find out the prediction, right?
Yes, sir.
And what is the prediction? How will you find out the prediction for x test? It is you w transpose x test, right? But that w is what? The optimal value. Basically, it is w star, right?
Yeah. Yes, sir.
Correct. No. So now I need to find out what is missing here. The w is missing here, right? Basically. So if you are able to somehow find it out, like what is w transpose u, and now all the data points actually lie on that same vector, uh, you just plug in that x test there and you can find out the answer. So basically here you wanted to find out w, and basically w you'll get it from the what, loss function of the linear regression. So you
Okay.
have to use that.
Since in loss function we are getting W is the
Correct.
only way, that's why we are using it.
Yes.
Okay. Okay, sir. Sir, one more question. In the loss function is W transpose xi minus yi equals square.
Hmm.
So do we need to put this C1U in place of xi?
Correct in this case.
Okay. Okay.
But now don't put it like immediately. Find out its gradient first,
Yes, sir. Yes.
and
Yes.
then plug in that.
Yes.
You will
Yes.
get some equation, and you
Hmm.
have the information here, no?
Yes. Yes. Yes.
So
We need to replace those
yes, correct.
numbers.
Yeah, yeah. Now I
Okay.
think you will get the answer.
Yes, sir. Got it. Thank you.
So instead of the xi, we have to place
CIU.
CIU.
Yes,
CIU, yeah.
correct, correct, correct.
Hello, sir. Hello. Hello. Hello.
Sir has went somewhere maybe.
What happened?
I think
Wait,
sir is not here.
Yeah, yeah. Sorry. What happened?
Yes, sir. I had my doubt in the previous question.
Okay.
What were you talking about when not to take average of the SGD?
So okay. So what I was saying is, so in the second thing, right? Stochastic gradient descent. Okay.
Yes, sir.
You do batch wise gradient here, right? Batch wise. So you take the first batch, and in the problem, what was the first batch? Out of the four samples, you'll have to take two samples, right?
Yes,
First two
yes.
samples. So this is
Okay.
the first two sample, 1 2 2 1 1 2 2 1. But in this formula, if you think about this, it is W not given here, right? So what is
Yes.
this? uh, like this is the weight vector with which we wanted to do initialization, right? And this is given to me as 0 0. Fine. So by using all of this data, okay, we have found out uh, this updated weight vector, but that is only for a batch, right? One batch. Okay, in the first step. Now how many data points we are having? Four. So I
Oh,
have completed the first batch. Now we'll have to go for the second batch, right? Because we have to, anyway we have to use entire data set for calculation of the weight vector, updated weight vector. Now in the second batch, either you can use the updated weight vector in the first, like which we have used in the previous batch, like this is the updated one, right? Updated weight vector, we have used this one here, right? For the second batch, which is 3443. Are you able to connect it here?
Yes, sir.
So now, shall we use the updated one, or shall we use 00 for this sample? That is the question, right? Either I can use the 00 for here also, and calculate the weight vector or updated weight vector for the second batch, or I can take this one. You can understand, right? So let's say I have one point here, so one direction I got here, and now I wanted a second direction. I use this first, the previous direction, to calculate the second one. Or I have this direction, I have another direction, I take an average of this and I'll get this direction. So the
Okay,
point
okay.
is,
Yes, I understood.
so I shall I use 0.08, 0.07 here, or shall I use 00? So if I use 0.08 and 0.07, then I don't, my point is I shouldn't be using the average here, right? When I should average is, I can, when I take 00 here and 00 here for both the samples, and then only I should average. Got it? But I'll confirm that with you later on. Maybe I'm doing a mistake here, so I'll just confirm that
Okay, sir.
in the next session.
Okay,
Understood?
okay.
Yeah.
Okay, sir. Understood.
Okay. Shall we proceed for this question? Let me see the answers. Okay. So Shmita is given answer. Yes, yes.
Sir, could you please discuss?
Okay.
So before we discuss, I just want to ask you, CI, instead of CI, we just substitute it and take the derivative, and then
Okay. Your
we
voice is
just
lost.
take the derivative, and
Yeah.
then we find the W star, is it?
Yeah, you can find out W star or W star U. Anyway, like, that is fine. Like, yeah, that is true. Let us see the solution. You'll understand. Like, you'll get the. I think you are on the correct track. Just the last step you are missing, right? So that will get it in. Is it fine? Shall we see the solution? Okay. So this,
Sir, could you please zoom in also?
what is it? Sorry.
Zoom in, sir.
I don't understand what you said.
So
So
can you please
she's asking
zoom
Zoom.
in?
Okay, both of you are actually talking at
Zoom says she
Zoom.
asked.
Okay,
Zoom.
Zoom. Okay, okay. Sorry. Yeah. Is that fine? This is okay.
Yes, sir.
Okay. Okay. So this is the loss we know, right? And what is the gradient of this? 2 times W transpose Xi minus Ya and Xi, right? Because we are differentiating this loss function with respect to W, because the only variable here is W, right? All others are constant. The data is constant, the labels are constant, and you got this part, right? Now what you do is, each Xi is actually, we know that it is some Ci times U, right? So I have just replaced Xi with Ciu. Is that fine? Until this part is fine.
Yes, sir.
Now you get this expression. Now what is the next step? To get the minimizer, you will have to equate this loss with 0, right? That you should do, right? You take a differentiation, the partial differentiation with respect to W, and you equate it to 0. And by equating it to 0, you get this. Like, you can just see that. Let's say here it is 0. So 2 goes that side, and you get W transpose U equals to summation of I equals to 1 to n Ci yi divided by summation of I equals to 1 to n Ci square. Is that fine? This is okay? Uh, let's look at this part.
So how did we get this?
Okay, so 2 is constant, right? 2 is multiplied with this expression. Can I take U common out of this expression, out of this sum?
Yes, sir.
Because U is multiplied to this quantity as well as this quantity, and can I take that U common? I can, right? So when 0 is here on the left hand side, this 2U can go to 0. Fine.
Yes, sir.
Then summation of this part and summation of this part, can I make it separate?
Yes, sir.
Okay, and one of the part will go to this that side. Let's say Ciy, summation of I equals to 1 to n Ciy will be going to that side, and this will remain on this side. Is that fine?
Okay, sir. Got it. Rearranging the terms. Got it.
Right.
Okay.
And then W transpose U is common in this quantity, so W transpose U I'll take common, and I'll remain with summation of I equals to 1 to n Ci square. Is that fine? Then W transpose U equals to what? Summation of Ci yi divided by summation of Ci square. Correct?
Yes, sir.
Yes.
And now I have summation of I equals to 1 to n Ci yi is 20, and summation of I equals to 1 to n Ci square is 100. So like, yeah, 20 by 100 is 0.2. So W transpose U, that vector I, or that coefficient I got as 0.2, right? And what is my target, or what is my question? I wanted to find the prediction, right? Prediction for X test, right? So what will be the prediction for X test? It will be W transpose,
Is equal to W transpose X test.
or in other words, W transpose 5 into U,
Five
right?
U. Yeah.
So can I say that it is 5 times W transpose U?
Yes.
So we already have calculated W transpose U, which is 0.2, and 5 times 0.2 is 1. So the answer is 1. This question was just like a manipulation of the terms, right? It is not like, I think it was just a mathematical manipulation of these terms. Correct, right?
Yes, sir.
I hope you understood the answer here.
Yes, sir.
Shall we proceed to the next? Okay.
So will you be uploading this file
Yes, yes.
immediately in this course or in the supplementary
No,
contents?
supplementary content. So
Okay,
immediately, Miss, I'll share that with my team. I think they
Okay,
will
sir.
take one day probably to upload.
Okay, sir.
Okay, and if not get uploaded, right? You have the previous files, week 1 to 4.
Yes, sir. Yes.
Yeah, so it will also get updated. Otherwise, you can remind me on Monday. Probably they will do it like immediately. Whenever, as soon as they will see the mail, they will just upload it anyway. Okay. So this is question number 4. Kernel regression with polynomial kernel of degree 3 is applied on the data set. Let the weight vector be given by. So weight vector will be in this fashion, right? Phi of x times, what is that? Okay, let's say some vector is there. Here phi of x is a transform data matrix whose ith column is phi of xi. What will be the prediction for this data point? So that if you know that, what will be the vector there? 1.3, 0.6, minus 0.2, minus 0.7 transpose. What is that vector?
So it's alpha is given, alpha
Yes.
star.
Yeah. And alpha is what? K inverse of y,
Yes, sir.
right? So uh, now you can think of that problem as, and you can solve.
But y is not given, right?
Yeah, but you don't need y actually. You if you remember the lecture, sir
Oh
has
yeah, we need only the alpha and the but the kernel we need, right?
kernel also we
Kernel.
don't need, right? What is the expression there? The if you think, if you know that kernel regression problem, there is right hand side sir has written something, right? So let's say W transpose X is my prediction. You need here prediction only, right? So what will be the prediction formula there? K of something, right? K of X and X test. Yeah. So okay, I think, yeah, correct. You need the kernel. Uh,
Yeah.
but
Okay, kernel is given, right, sir? The
hmm,
polynomial degree kernel, but the xi's are not given. So how do we?
okay, okay. Can you just, okay? If you have notes, just open it now. Try and see if you can do. Uh, then maybe we can, or you just try it out like first. Then I'll tell you. Polynomial kernel is given to you, right? What is that polynomial kernel of degree 3? How does it look like?
Xi xj plus 1 to the power 3, right?
Uh, okay. In Okay, and what is this giving me?
That's alpha. Alpha star.
Alpha star. Okay, and you sure that k of xy is what? Then k of xy you are finding out, or k of xi xj you are finding out? Xi xj, right? Okay, fine. So it is one plus, right? One plus xi xj. Is that fine?
So it is 1 plus xi transpose
Xj,
x test whole to the power cube, whole cube.
correct. So basically, you have given that x test. No, x test is given to me, and all these values are given to me. These are alphas, and now you will need to find out one plus x1 into x test, right? Or
Okay, you won't need the excise because anyways it's all zero.
zero.
So
Yeah,
yeah,
yeah.
got it.
Is it done?
Yes, sir.
Okay. I will posted the answers. One, okay, one only. Okay. Let's see. I think it was easy, right? Not like difficult one. Because all are ones, no? Here alpha into k, right? That is my answer, right? Okay. Let's see the solution. This is the answer, right? The prediction. Summation of I equals to 1 to n alpha I into k of x test into xi, right? The kernel given is the polynomial one, right? 1 plus x transpose y cube. Now our test point is 0 0 0 0, and the dot product of, okay, you can think of this, right? So kx test into kxi. So one, why everyone is one here? Because this is x transpose y, basically it is not y, it is x transpose or xi transpose x test. If I wanted to use the kernel over xi and x test, right? So every time it will be 0 here, and 1 cube is 1. So that's why you can see that it is 1 1 everywhere, and alphas are this one, right? This vector 1.3, 0.6, minus 0.2, minus 0.7. So basically it is the sum of all these alphas. 1.3 plus zero point 0.6, 1.9, and minus zero point 0.9, which is 1. So it should be 1. Just look at the solution if you didn't get it. I think it was, I don't know where you have missed the point, but just, yeah, okay, that's fine. You can just look at this solution. Okay, I hope this is fine. We can move forward. Okay. So this
Yes.
is question number 5. Uh, if you want, I'll just zoom it a little bit. Okay, but these are the data points 1 2 3 1 minus 1 4. The projection of the label vector onto the span of the feature vectors of the data points. So there are 3 data points. Okay. Above you have the 3 data points. How does they look like? So 1 2 3 1 minus 1 4. What are they?
Three data points with two features each.
2 features, right? And what is the second line? The projection of the label vector onto the span. What it indicates to you?
Why?
Y, right? Because this, if you take the projection onto this in the feature vectors, that is actually your Y only. Predict the label for the new data point 7 3 using the linear equation. So you have data points. You have, let's say you have Y, and now you wanted to predict for 7 3. How will you do that? What is the first thing comes into your mind? What you will do first?
W star, right?
Yes, yes. And what is the formula for W star?
X transpose W equal to Y.
No, no. It is XX transpose. The W star will be XX transpose inverse XY, right?
Right. Sir.
That
Yeah,
is your,
SS transpose inverse.
yeah.
Yes, yes.
That is your W. Now, and what is the prediction? Whatever W you have, transpose this X test, right? What is X test here?
Yes, X test is 7 and 3.
Yes. Now you can find it. Yeah.
Sir, are you there?
Yes.
Sir, this 2, 11 and minus it is the Y prediction, no, sir?
Uh, yes, it is Y prediction, but if you remember that sir somewhere is mentioned, no? So it is actually it's uh, Y prediction, or you can say that it's,
It
let's
is
say,
in the
Y.
span of the feature vector,
Yeah.
no? So
So
it is actually,
Y only, right? Because it is, let's say it is W star, fine. Let's say it is W
Yes.
star.
Yes,
But
sir.
if you remember that error vector, and that sir has taken, no, that it is perpendicular to the span, that entire
Yes.
span. So that you can think of this as uh, Y only, because anyway that perpendicular portion, right? It will not affect much because it is anyway perpendicular to your feature space. If you remember that solution there.
Then, if it is a projection, then can we consider this as X transpose W? Means this 1, 3, minus 1, 2, minus 1, 4
Mhm.
multiplied with W, we will get 2, 11 and minus 8. Is it something like that?
Yeah, or you can think of this as Y only, right? Why to uh,
Okay.
bother about it, right? If you can
Okay.
think of it Y, uh, then also is fine, right? Because X transpose W star, right?
Yes, sir.
That is equals to X transpose. Let's say this is perpendicular. There is one perpendicular component. I hope you will remember that X transpose perpendicular component of that
Mhm.
W, that will become zero, no?
Yes, yes. Okay.
Uh,
Right. Yeah.
so yeah, okay. So how you are solving it? Actually, sorry, I think I will just give you the wrong end. Uh, how you are solving this problem? This is like W only, right?
Sir, actually, the projection is, I
Yes, yes,
think,
sorry. Yeah, yeah.
W transpose,
Correct.
sorry, X transpose alpha
W
star,
is the
right?
Y prediction. So this 2, 11 and minus 8 are the predictions, not the actual Y's, right?
Yes, sir. That is what.
Yeah.
Sorry, sorry. I just missed that. Okay. This is actually the predictions for all those data points. So basically your X transpose W, it should be your predictions, right?
Yes, sir.
And
From there
you
we
don't
are
know,
getting
yeah, you
W.
don't know W's. Sorry, sorry. Yeah, W1, W2 will have to calculate that.
Ah,
And now that whatever W1, W2 you get it, then you can predict easily.
Yes.
Because then it will be W1 X1 plus W2 X2.
Yes. Correct.
Yeah, sorry. I just I
So
wanted to say
then
that
W star, what do we use as Y then?
no, you don't need Y now, right? Because see, the predictions will be there. They are what
Acha,
X
you
transpose
directly
W.
get the okay. You directly get the this from X transpose.
W.
Okay, X transpose W star. Okay, from there you get it. Got it.
Yeah, because X transpose W star, and if these are the predictions, right, which are there in the feature space, they should be equal, right? So X transpose W star should be equal to Y predictions. So you understand?
Sir, actually, regarding the geometric interpretation after this, after these questions, if you can just explain once again,
Okay.
like, yeah, thank you.
Okay, I'll maybe I with this just give me a moment. If you have, I'll just download that part, right, and I'll show you that it will be
So,
easier.
how many more questions do we have?
We have 10 questions, but it's fine.
Oh,
Like
God.
we can
Okay.
as much as we can do, and we'll stop. No issues. Give me a minute. I'll just show you the geometrical interpretation for this, right? That will be actually a good thing to have, right? Then only will be able to understand so like much of the problems. Basically, numerical part is fine. Numerical you can actually solve anyway. Mm, okay. Week 5, right? Geometric interpretation is here. Are you able to see the screen?
Yes.
Yes.
Yes, sir.
Yes.
Okay. So, why it is not moving? So this is our solution, right? X transpose inverse xy, and this feature space, right? Like what the features space is what like. So if this is feature f1, for, like along the examples, what you are saying that okay, this will contain one vector, and f2 is another vector, which is a weight vector. Now what you are actually plotting in it in here, the linear combinations of all these features, right? And this yellow shaded portion is the feature space, which is alpha star f1 plus alpha 2 star f2. Is that fine? But this f1 f2 written in this fashion, right, is actually x transpose. What is x here? How does this matrix will look like? So this is row wise, it is x1, right? X transpose
Yes. Sir.
matrix
Yes.
row wise is x1, x2, x,
Yes. Yes.
because f1 f2 is like this, no? So x1 here, you look into this side, left side, it is x1 is this, x2 is this, x3 is this. So basically you're saying that this times this is X transpose alpha. Fine, this okay?
So
Why?
basically, the matrix is the same only, right?
Correct,
Matrix.
correct,
Yeah. We don't have to do an actual transpose, right?
correct, right. So here, when my y is not in the feature space, what does that mean? I will not get the solution to this problem, right? What you do in that case, you just project that y onto the feature space, and let's say this is your projection here, right? So what is this projection? It is X transpose alpha star, this y, and what will be the error vector in this case? Y minus X transpose alpha, right?
Yes, sir.
Yes.
Okay, so now you are saying that, and then what else we can say from this part? This error vector is perpendicular to this vector, which is X transpose alpha star. Correct. What we are saying here is this point, which is in the feature space, is a linear combination of what? All the data points. Is that correct? Let's say you have x1, x2, x3 data points. You are saying that the prediction for any test point will depend on what? Or your W star, which is a weight vector, is dependent on what? Or it is a linear combination of all the data points. Correct? No?
All the
Yes.
data points except this one, this projected one.
No. The projection is the label. Projection is for label. No, we are not
Yeah,
considering anything about
yeah,
X test here.
yeah.
It is that if you wanted to find a prediction, right? That prediction should be in the feature space, right? Or the span of the features or span of the data points. Let's say, correct? No, it because
By telling in the feature space, it means the linear combination of all the data points in the plane, right?
correct, and
Okay.
that should be, and whenever you wanted to find out any prediction, it will be in that feature space. Fine, don't worry about the prediction yet. uh, what we are seeing is the W star which is required, which is the optimal weight vector which we need, is it should be in this space. Fine. Now what we are saying that, and that W star is also a linear combination of all the data points. Now this linear combination, right?
Optimal weight vector, geometrically, what we mean by the optimal weight vector? Normally, we calculate it. Optimal weight
Optimal
vector means
vector
what?
is like, okay, let us say, okay, I think the diagram.
Geometrically,
Yeah.
calculation, we know.
Okay, I'll see that any 2D diagram is there. I'll try to. Okay, fine. So, okay, think of any problem, linear regression problem in 2 dimension.
Yeah,
What will be that? Let's say you have x feature on the x-axis. Fine.
yeah,
You have y on the y are the labels. Suppose, okay, and you have x1 y1 pairs. Are you able to understand that? Like, if I'm
yeah, yeah,
correct?
yeah.
So your x and y is here, and you have all the data points. Fine, and you wanted to find a best fit line through all these data points. Fine, how many lines you can actually draw through these data points?
Draw
Infinite,
through,
right? Okay.
through these data points.
So
Infinite lines we can draw.
okay, 1 minute. I'll try to connect it. This is actually, this is not my laptop, so I'm
Okay.
not. Okay, let us see if I can upload.
Not this one. Bunker.
I'm not able to write on this. Let's see if I can write. Uh, okay, no, fine. Okay, No issues. Let me okay. Let me show you one diagram. You try to tell me. Two-dimensional data set on the graph. We'll take some simple example if we can get. Let us say, okay, this is a good example here. Are you able to see this?
Yeah.
Let us say on x-axis is your features and y-axis are the like labels, corresponding labels, and this is how your
Yeah.
data looks like, right?
Yeah.
So if I wanted to pass a line through all these data points, how many lines you wanted to pass here?
Passing through the origin.
Yeah, let's say passing through how many lines I can actually draw?
Many lines we can draw.
Yeah, infinite, right?
Yeah,
Now,
infinite.
which will be the best fit line you feel? Can I say
With
that
less minimum error.
minimum error? And it can be going through this,
Yeah.
right?
Yeah.
Like something like that.
Yeah,
Let's say
that is
45
okay.
degrees to
Yeah, that is okay. Yeah.
So what does that mean? The error will be less with respect to that. And this line, right? This line is actually a W star. Understand?
This line is a W star.
W star, correct. Because this line is what? Like it's a vector, right? That
Line
vector
is a
W
vector.
yeah.
Yeah.
Correct, na? So each of the data point, if you think of as a vector, so let's say this is a vector. All of these data points are vector, considered as vectors. And if I am passing any line through this, consider any point on that line that will be that you can consider as a vector, and that is your optimal weight vector basically, right? So any weight vector you are thinking about, basically it is a line, correct? Because if you multiply that vector with any or with real numbers, you will get a line only, right? C times W, what is that? Basically a line, right? Are you
So
able to?
basically, we can say that in a 2D space, we can consider as a slope of that line.
Yeah, but if you are ignoring intercept, so if you are having that
Yeah,
intercept and
if the
that will come
noise
as
part
bias,
is removed, huh? The noise
not
part,
noise part, the bias part.
the bias part.
Basically in this MLT lectures we are not considering the bias. We are just saying that w1 x1 plus w2 x2 plus w3 x3, right? We are just taking the linear combination without taking that bias part, which is w0. So
Yes.
whenever any bias will come, right, so then that line will not go through origin, it will go through that intercept, right?
Intercept.
So in our simplification of the study, we are not considering the bias, and that's why all the lines, right, they are actually passing through origins for us in this MLT course. So that weight vector is basically a line which is a best fit line, correct?
Mm-hmm.
Okay, now if you think about this in this diagram is in a 3D space. Okay, so your data is scattered into 3D space. Now you wanted to find the best fit line through all these data points, which is your W star, which is a weight vector. Now it will not be a vector, right? Or sorry, it will not be a line in this case, right? It will be a plane. It will span a plane, right? Because your
Yes, sir.
W star will be a two-dimensional vector. So if you think of this, right? Let's say I say a line here. What will be the line here? Mx, right? Y
Yes.
equals
Yes, sir.
right?
Yes, sir. Because it passing through the origin.
Correct. And this M is actually
Yeah.
your weight vector.
Correct. That's what I was saying.
But,
Yes.
but this M is what? Single dimension, right? One
Yes, sir.
dimension, right? Because
Yes.
it's a scalar. Basically, it's a slope. Slope is a scalar here. It's a one-dimensional data,
Correct.
and that's why when you can think of this as W as what? Let's say line in this two-dimensional case, but
W represents the line, slope.
slope. But
Slope.
if you multiply with x,
Yeah, multiply with x, then it is a line.
it will be so then it will represent a equation of line, right? Basically.
Yeah.
But if
Just
in
like y is equal to mx plus c, m represents w, and c is 0 here, right? Because
correct,
passing
because
through
we are
the
saying the intercept, you are
right.
actually making it 0.
Okay.
Now
Okay.
if it is a plane like this. So here your data is in 2 dimensions, right? Each xi is in 2 dimensions. So your linear combinations will look like what? Let's say you have data as suppose x1 is so w1 x1 plus w2 x2 is matrix, right? How that matrix will look like? X1 is in 2 dimensions, x2 is in 2 dimensions, and your weight vector is in 2 dimensions with w1 and w2. Correct, right? Are you able to understand that part?
Here our data here is this one, na?
Yes,
F1,
sir, because
F2,
there are two features. Yes, sir, two.
two
Correct.
features, na? 2 dimensions.
And this w is basically is in 2 dimensions. So if I wanted to find out w1 x1 plus w2 x2, will that be a line or will that be a plane?
We will pay plane because
It will be a
actually
plane.
Right, or you can say that it will not be a plane. Basically it will be a some y, right? So w1 x1 plus w2 x2 is since it is a dot product of w and x, right? So it will be a constant, so it will be one point in that plane. But if I think about the span of w, only w1 and w2, that will be what? A plane. That will represent a plane, right? The span of w.
then why we call it R3? Because it is R2, na? 2 dimension.
What is R? No, 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 that will be okay. W is in not R3, right? It will be an R2, right?
Okay, yes,
So
yes.
here, what they are saying is that features are
In
in
three
R3.
dimensions. Yeah, features
Yeah,
are
because
features
it's got x1, x2, x3,
X3.
Yeah,
three
three
points.
dimension.
Yeah. So then
This
it's 3 dimensions.
we are not considering x1, right? X1 is in 2 dimensions, right?
Okay, okay, okay.
Each of the data
X1,
points is in two
yeah.
dimensions, right?
Horizontally F1, F2, yeah.
And you are actually multiplying that x1, x2 with w1, w2, na?
Yeah, yeah.
So see, d equals to 2 and n is equals to 3. N is number of examples. Here we are plotting the features.
Here X1, X2 is representing F1, F2, right? We
No,
are
no,
taking
no.
the values of F1, F2 we are taking. Na? Here for X1, we are taking the data points. F1, F2, value of the F1, F2 is representing X1, X2.
Okay, okay. 1 minute. Give me,
Am I right? No?
no, 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 1 minute, 1 minute. I think
Okay.
you're getting confused. Just give me
Yeah,
2 minutes. I'm just
yeah,
presenting my screen through different
yeah,
devices.
So
yeah,
the
yeah.
main concern I was having was in that diagram that you had shown, na, that they say that y minus that is what is that x alpha star is perpendicular to all the data points in that plane. So it's perpendicular. So it's the product of the two will be 0. So that I understood, and then you replace w star in place of alpha star. It satisfies the equation. So matlab we say that alpha star is w star, right?
Alpha star is W star.
W star.
Okay.
Yeah,
Basically,
but
it
then
is.
in the but in the I mean
Uh,
in the further lectures we are getting a different equation. W star is equal to x alpha star. So that is what is like, little bit there is a like
okay.
conflict of thing
Got it. Got
there
it. Got
going
it.
on.
Just a minute.
Yeah,
Okay.
yeah. The same thing I confused with that also. Because
Uh,
the same geometrically not understanding. Numerically, we just understand the formula is this, formula is this.
okay. Okay. 1 minute.
Okay, let us discuss.
So sometimes understanding it geometrically, right? It might be little tough.
Mhm,
Just one
mhm,
minute.
mhm, mhm.
Okay, just give me a minute. I'll just join it through different. So what happened today is my laptop is not with me. Otherwise, okay. Are you able to see my screen?
Yes, sir.
Am I audible now?
Yes, sir.
Yes, sir.
So your x1 is in two dimensions, right? X2 is also in two dimensions. X3 is in two dimensions. Fine. Okay. What do you mean by two dimensions? It is, let's say, uh, x1 is, let's say, uh, 120, 150. What does that mean? Or let's say, mm, weight and height, right? Weight, let's say weight is 50 kg, height is, let's say, 150 centimeter. Fine. So this is weight, this is height, right? For the first person. Is it fine?
This is representing a point on two dimension, right?
Correct.
Am I right? No?
Correct, na?
Yes.
Yes.
Now x2 is, let's say, 60 and 160, and x3 is 70, 170. I'm just taking random numbers. Before that, try to understand this part. This is your, let's say, uh, we are not talking about three dimensions, or let's say, okay, let's say three dimensions also. So suppose this is my height, this is weight, okay, and the corresponding label will be, let's say, y is, when you say about y, what should I get? Let's say body mass index, right? It is 2, here it is 3, and here it is 4. Is that okay? Just some random numbers. Is that fine? This is my y. So x1 will be what? Which vector? Weight as 50 and height as, let's say, 150. So this is the data point, right? In this plane,
What is the 2, 3, 4? This
some label, y label.
level only. Yeah,
Okay, I don't know what label is that, but I'm
yeah,
just.
yeah. Index. Some level is there. Index.
So this x1 will be here, right?
Yeah.
50 is 150. So is that a vector? So x1, which is equals to 50, 150, I'm
It
considering
is a
this as
vector.
one vector.
Vector.
Okay.
Hmm.
For now, I'm just saying that it is a data point, but actual data point will be what? Let's say here it is 2. Okay. I'm saying that 1, 2, and 3. And let's say it's 4. So my data pair x1, y1 is what, where? Somewhere here, right?
X1, Y1.
So this is my x1, y1.
2. 2 here.
Okay, let's say, yeah. Okay, what this tuple basically is, or I can say that this is basically a data point. To think of this, right? When we
This
generally use
this 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 is in a space, na? X1, Y1.
one. X and y are here in two dimensional cases. When I say that x1 is 5, okay, x1, y1 pair, and I say it is 5 comma 1. So x1 is here, x2 is here, x3 is here, and their corresponding labels will be, let's say, 1, 2, and 3. In that case, my data point will be here, right, which is I call as x1, y1, right?
Okay, okay, okay.
So this is basically x1 and y1, and this is one vector. X2, y2 is another data point, here is another vector, and x3, y3 is another point. This is another vector, right? Something like this. Okay, but this is one pair of x and y. But in three dimensional, how this pair will look like? So x1 basically is a vector in two dimension, and this is some real number, right? And similarly, I will have other numbers as well. So this will become my entire space. I don't know. I'm just randomly generating these parts. This is x2, y2. This is x3, y3. Okay, but I'm not worried about y. Let's say where my feature space is lying. So x1 is here, this part.
Mm. Yeah.
X2 is let's say 156. So somewhere here, and x3 is here. So if I think of this as one vector, this as another vector, and this as another vector. So the all the linear combinations of all of this will be where in xy
This
plane,
plane in
Yes, in
XY
the
plane.
same plane.
or
Yeah.
yeah, this plane, right? Or I can
Hmm.
extend it to somewhere and like this. So this will be my plane.
Yeah.
Now if I just wanted to draw a label vector, so y will be what? Only label is, let's say 2 3 4.
2, 3, 3, 4.
So one vector, like this. Is it into that plane, the below
No,
plane? No.
no.
So now, or okay, anyway it will not be there, but uh, we wanted to predict it for the new data point. So let's say if some data point comes in here, I need to find out the corresponding label for that. But instead of looking that this feature space as like this, okay, okay, and in this case it will be okay. So y will be what then? Here w1 x1 is w2 x2 plus w3 x3. Okay, but and this is what? Dot product
Dot
basically,
product. No.
right? So they are like some scalars, right? So the w1 x1 is some real value, this is another real value, and this is another real value. So the final product will be this real value. But if this is not the simple dot product, because x1 is in two dimensions, so it will be like how this x1 x2, or I sorry, this will be, let's say, x1 x2. Okay, when I say like this, what does that mean?
Transpose.
But what is the, that is okay, transpose is fine. What is the dimension of this? 3 by 2.
3 by 2. Yes.
So when I say
X1 is 2D. So yeah, two features.
and this is what? W1.
W1, W2, W3.
Or sorry, we don't need W1, W2,
2,
W3.
3, 2, 3, 4. No? Normally it is represented 2, 3, 4. No? But we
That
exemplified
is
it.
why this is, we want only W's, right? W's are only two dimensional.
Two dimensions, right? Is that okay?
W1, W2.
But
Uh,
I think it should be 3, right?
it should be 3. No? Why? It is W. W1, W2, W3 is equal to Y1. Y. It is equal to Y.
3 cross 2 into 2 cross 1 will give 3 cross 1 matrix. So W matrix will be 2 cross 1.
3 cross 1.
No, that is Y is 3 cross 1. Like
Y should be 3 cross 1.
Annapurni is saying, yeah, it is
Should
2
be like
cross
W
1.
and
Correct.
W2.
Yeah, 2 cross 1.
Uh,
W1, W2.
okay, basically it should be like
Your
this.
equation is wrong.
No, not wrong.
Yeah, yeah. This one is different.
Should be like this. Okay, I'll tell you. X1 basically, can I say that it is x11, x12,
Yeah,
x21,
yeah.
x what is it? 22,
2, 2, X31,
x31, x32. What is that?
3, 2.
So x1 is basically a vector of x11 and x12, right? So this correspond to height, let's say, or weight, and this correspond to height.
Right.
So one is for weight and two is for height, and x1 is basically the first example, and like that. And so the combination will be like this. Let's say y1 is equal to w1 x11 plus w2 x12. So your here it will be like this: y1, y2, y3. Is that fine? Now
Yeah,
this
yeah. Now it is fine.
correct, right? Uh, so y1 is basically this. Y2 will be w1 x21 plus w2 x22, right? Correct. But I need to find out this w1 and w2 because I have all of this. How will you do that? So these are the actual labels y1, y2, right? I hope you understand that. And then you found out the predicted labels. But what we are saying is this w star, which is the optimal weight vector, is a some linear combination of, or is that okay? We are saying that this w star is nothing but some linear combination of x transpose alpha star. Uh, does it
Yeah.
look fine?
It is the same as saying some linear combination of feature vector.
Yes, right. All the features, right? So that means how does that look like now? So this x1 x11 x21 and x31 I will consider as f1, and this as
X2,
f2.
F2, F2.
Okay, now I'm just plotting f1 here, f2 here. So uh, let's say here is f1 and here is, let's say, I don't know, f1 or f2, that's fine. But the span of this will also be into this feature space, right? I hope it is okay. Till now, it is fine.
Yeah.
Sir, this I understood, but then why do we substitute W star as alpha star? That part I didn't understand.
Because see, it should satisfy this equation, right? Okay.
W star is not the same as alpha star, right?
No.
So then why do we substitute W star as alpha star in that equation? And it still satisfies that equations.
Right question.
I will just
Anyways, I mean, we can respond to this later, but then if you want,
no,
like,
just just a minute.
because
Let's
it's
X
already 8
transport
o'clock.
double. No, I'll just finish it off quickly. Don't worry about this. Okay.
W is a linear combination of data points. Correct?
Yeah, that is
So
correct.
is alpha star, sir,
No, no,
but
no. Alpha is the weightage. You're taking all the data points and taking a weighted average. That is your W. If there are 10 data points, alpha will have 10.
Okay, just a minute. I think this is not like this.
right, sir, because X is the same dimension space is the same as that of the number the number of data points is.
Okay.
No, but I wasn't understanding the graphical representation. Sir, professor, he substitutes W star in that equation in place of alpha star, and it agrees to that equation also. So then, but W star is not same as alpha star. So that
No,
is
I don't
why.
think he didn't substitute like that. He always takes W star as X transpose W alpha star. They
Okay,
are not
maybe I
same.
must. Okay, yeah, that's what because yeah, because
No,
I must have been mistaken.
alpha is the weightage given to the various data points by which you arrive at the W.
Correct.
No, sir
That
has
is how it is. That is what the formula also says. Like X star is equal to sorry, W star is equal to X transpose alpha star.
see, basically your W star should be a linear combination, right? Some linear combination of
In the lecture, alpha star was taken as the K inverse Y. K
no,
is
no,
the vector.
that is different. That is the kernel regression thing.
Yeah, in the kernel regression.
Here it should be like W star should be actually be equal to X transpose alpha star. So we are taking uh, okay, I think there is some mistake.
So maybe there's some. I will just watch that lecture again. So you proceed, sir, please. I understood.
Okay, let me check that also. I think there is, I'll log out from here. Maybe
in the lecture, sir has substituted W star is equal to alpha star.
Yeah, he has substituted it. But
Yeah.
see, basically,
And why he has substituted, we could not do that.
okay. Okay, let's finish like one or two questions more, and then
Yeah.
maybe I can just
Yeah. Let us finish the questions first, then we will discuss. Today
just
the revision session is also there.
okay. This question number 6. You just finish it off. I'll
Yeah,
let you
yeah,
know.
okay.
Part.
You will share this PDF, na? The question answers.
Yeah.
Okay.
Okay. 1 minute. F1, F2, F1, F2 times alpha 1, F2. Okay. So F1 basically is x1, x2, 3, 1, and this is 6.
So what is the last option?
Yeah,
It's,
last option is not clear. Yeah. Now,
yeah. Yes. Thank you.
C is definitely true. A, I'm not sure.
Okay, the question is all the data set is given to let W be the W after linear variance is that y of xi square equal to 0, where f of xi is W transpose xi. The W is the result of overfitting. Every data point in D is on some hyperplane in RD. Is that correct?
C is correct. D,
What
B
about
is,
C is correct, sir.
yeah, B is not correct. No, it is always RD plus 1.
correct?
A
Because
and C are correct, no?
Whether A is correct, something matches. Does that always means it's overfitting? It is a result. It can be a result, but we are something like, is it a
it will
definite?
not. Actually, it shouldn't be the overfitting. If it is overfitting means it is like your error between your actual labels and the
Okay,
predicted
okay,
labels
okay,
are
okay.
equal to 0.
Yeah,
And if
yeah.
it is like that, then all the data points should be on the line, right? Basically, they or line or that hyperplane. So in the same space, it will be there, and this is not going to be true. AI should not be true. What about uh, what about D? Option D.
So error is 0, na? It cannot
Yeah,
be greater
yeah,
than 0.
yeah, yeah. It cannot be more than 0. It should be 0 only.
Which what are you talking about? Option D. You're talking about
D.
D.
Option D.
So you have that ys y1 to yp is a production on the span of feature vectors. Then y minus yp is greater than 0, the length of y minus yp. Will that be?
No, it cannot be
No,
more than
So
D is
they
not
are in the
true.
same plane. No, they are all in the same hyperplane.
So
So
they should be equal to 0, no?
yes. So
Yes,
yeah.
y minus yp should be equal to 0.
zero.
Equal
So
to
it is
0.
not true. The statement is not true. Only C is true.
Only c is true. Correct?
Mm. Correct. Correct.
Okay. Let's go to the seventh question. X square minus 2x plus 1 is a polynomial or the function. We are trying to find an x at which function value is minimum with variance by initializing x not equal to 0. After how many iterations does the algorithm stop? This is like simple problem. It's not like really like it's you can solve it by using calculus.
X is 1.
X.
X is 1.
At x is equal to 1, it will be minimum, right?
It is going to be minimum.
But
Okay.
x is equal to 1.
Correct. But still, it will x is equals to what is the question was?
Next number of
How many iterations it was asked? No.
The scalar is 0.5. Some notation
You
you
are
are using.
you are giving the answer for this. Okay, fine. This I hope all of you know this, right? It's not like difficult for you.
Yes.
Yes, sir.
Okay. We have n data points x1 to xn and labels are there. We form a new data set of n points given as x1 y1. That is okay. Like it's a simple same thing. We run PCA on this data set and get L1 as a line along the first principal component. On running linear regression on D, we get L2, which is a form of Wx. Assume that the summation of I equals to 1 to n xi yi is equals to 0. What does that mean? Okay, anyway, the data set is centered, right? Basically, so we're
Yeah.
trying to say something. Uh, okay, SSPD is sum squared perpendicular distance and sum squared vertical distance. This is like you have two components for the vector. One is along the like let's say which is perpendicular and which is one is vertical. Fine. The SSPD, that is sum squared perpendicular distance from the data points in dataset D to L1, is the minimum possible uh, to any line in R.
Sir, what is vertical distance? Perpendicular distance? Okay. Vertical.
Okay, what is perpendicular distance? What do you understand by that?
That is actually that error we are saying, no? That one, no?
Okay, I think that is not the case here. This should be the, let's say you have okay, fine. Let's say this is error distance and this, okay, I don't also know what is it.
What is the difference between perpendicular and vertical distance? Perpendicular, vertical. Is it talking about the
Well, I
projection?
think
Projection.
okay, I think
Projection.
I also
Projection
don't.
and
Okay, one minute. Let me also understand this part. Okay.
W tilde and W tilde perpendicular.
I
Is it
think it's not
talking?
about that. I think it is
Okay,
about
it is not.
PCA,
Then
and
what is the
I think that
what is the not understanding the question?
let us see that.
Okay, answer is this PCA.
Okay,
Okay, along the y-axis, vertical distance.
I think okay. Don't worry about that. You can just do it later on. Let's say this one.
Okay.
Let's try to solve this part. Okay. And those who wanted to stay back for last 10 minutes, yeah, you can stay because I will answer you to that part, the other one. Once the session is over, you can stay.
Will you be sharing this PDF?
Yeah, this one I'll share. I'll be sharing.
Where will I find a link?
Supplementary content.
Thank you.
Yeah, maybe a suggestion you can put it in Discord as well, because in supplementary content so far
Okay.
only first 3 weeks are there. So fourth week itself is not uploaded there.
I have asked, right? Like somebody has said it is uploaded.
Sir, no,
There
it's
in
not
discourse.
uploaded.
It's there in
Huh?
discourse. Yes.
Huh?
It's not there, sir.
No, in
Okay.
supplementary
Okay.
content, 3 weeks are there. fourth week is not there.
Not there. Okay, fine.
Discourse, yeah, discourse. I got it from discourse. Solve with us for fourth week.
Fine, fine.
That
Okay.
was a TA session question,
Yeah.
TA discuss question,
So just to put it in discourse, I think
Sure,
then
sure.
it's immediately available.
which
No
was
ad.
prepared by Pulkit sir.
Yeah.
Okay, I'll upload it in both the mediums, right? Okay, I'll put it
Okay,
into
okay.
discourse also and put it into subject.
Supplementary upload takes more time because they are sent to the, I think,
Okay,
admin or
discourse
the.
I will add. After this session,
Yeah.
I'll add into the
Yeah.
discourse.
I
No
Okay,
think.
issues.
because we need immediately, na, so they will
Sure, sure,
revise it.
sure, sure. No issues, no issues. That I
Okay,
can
thank
do
you.
it like
Okay,
easily.
thank you. Let us proceed.
Okay, and those who wanted to see that why Sir has replaced W star with Alpha star, right? Uh, those can stay back after this. I will show you why it is like that.
Revision session are also there from 8 to 10, sir. It is 15 minutes
Yeah,
away.
you can leave. Like those who wanted to leave, they can
Okay,
leave.
no.
Okay,
Okay.
issues with that. Anyway, this session is streamed, so you can watch it later as well. No issues. Uh, Either if you wanted to solve this, or I can show you the solution. Maybe you can do it later. If you wanted to join that session, I can show you the solution. So this is x and y. Shall I show you the solution?
Yes, sir.
Yes, sir.
So this is the Gaussian kernel, right? uh, Exponential, like e to the power minus xi minus xj square upon 2 sigma square. Sigma square is given to me, and sigma also you can easily find it out. Anyway, it's a square root of that. And the formula to the prediction is this one, right? Alpha I into a kernel of x nu into x nu comma xi. So x nu is like x test, which is 1 1, where xi are the points on the training data set. We have given alpha in the question, right? So alphas are given. I know x, I know y. Now I know alpha. I know what kernel function we have to use, which is the Gaussian kernel. Now we'll have to find out all of this. Like for first data point 1 0, this is going to be the numerator part, right? X nu minus x1 square. And likewise, we have found out for each of the data point, and then uh, we have found out the kernel values. So e to the power minus 1 by 2 sigma square, and all of these values are e to the power minus 1, e to the power minus 1 for the first data point, second, third, and the fourth. And the prediction
So
will be
I had one doubt, sir. Why are we not taking that 1 upon 2 root pi sigma, that value?
which one?
Because here we are not going for any logarithmic
This one,
this or
right?
something.
This is the kernel function, no? Gaussian kernel. It is not 1 upon root 2 pi sigma, right? Or are we using that?
No,
No,
I'm
No,
asking why are we not using that?
no,
I
this is
think
since it is a constant.
it doesn't
I
matter, right?
think
Again, it
this is
will be
just
the
a kernel definition.
Yeah.
yeah,
Doesn't need
yeah.
a run.
If you do that also, what it will change for each of the data point, you will have that extra thing, right? 1 upon root 2 pi sigma, some constant. Let's say c, correct?
Hmm.
So this will be the first value will be c times c to the power minus 1. The second will be c times c to the power minus 1. Third is c times 1, c to the power, like that, right? And when you predict it, what will happen then? C will be common, right?
Yes, sir.
Will that like affect the value, the prediction value to you? Basically, it will not, because okay, what will happen, just to it is getting elongated or contracted, right? We are actually thinking in terms of the vectors, so it does not actually affect much, because then uh, you can use it, you can.
Because in the tutorials also, it's been shown like this only. I was wondering why you have not taken, because it's a Gaussian kernel, means Gaussian, that formula comes into that, right? 1 upon, and here we are not taking any
No, no.
like, you know, we're not
No.
taking a log,
Gaussian
and we're not
kernel is
taking
Gaussian kernel is a name given to that
Yeah.
function because it looks like some the Gaussian distribution PDF, right? This is exact. It's not exactly the probability density function, right? For this is the because it looks similar to that PDF. The name to this is as Gaussian kernel function. Basically, it is
okay,
used to map the data points from like this is a mapping function, right? Basically,
okay,
you have
okay,
one data
okay,
point and
okay, okay, got it, got it, got it.
like the polynomial function, it is kind of like that. It looks like that. That is the name of it. You it's not required to use that 1 upon root 2 pi sigma. It is not the
Got it,
PDF.
sir. I think I've that it's similar to the kernel PCA part.
Yes, yes.
Got
It's
it.
same
There is
same
no
thing.
need for you to normalize it to,
Yeah.
Okay, got it,
you
sir.
get that only for a normalization in terms of a probability, because
Probability.
it is a
Yes.
PDF. Here you don't need to normalize it.
No, don't need to normalize. Yeah,
Yes.
got
Yes.
it, sir.
Yes.
Got it.
Okay. So I'll share that PDF with all of you. Those who wanted to stay back for 2 3 minutes, like maybe 5 minutes. I will just share my screen in another device. Okay. Just stay for 5 minutes. I'll finish it off then. Okay. The okay. Is my screen visible? Yes. Right.
Yes, sir.
Yeah, visible, sir.
So we have seen this part, right?
Yeah.
Yes, sir.
I'll write it again for you. So, how was my data set?
Sir, you're not audible.
Sir is writing.
Yeah, just because this device, the both devices are here. No, it's like you'll get like voices, two voices. That's why. So this is fine, right? Until this part.
Yes, sir.
Okay. Times W1 W. Is it fine? Okay. Until I think this part is okay, right?
Yes.
Okay. Now we were thinking about this part, right? This feature vector part. Hmm?
Yeah, yeah.
So let's say that one, two, y. So till this part is okay.
Same. It's the same W1 and W2, alpha 1 and alpha
What
2
is
star.
this F1?
This is X1, X2.
This one, and this one,
Yeah, X1, X2, X3.
and this was F2. Like all this green, this if I just take it into the vector, this will look like F1, and this will look like F2. Is that fine? So, and this part is also okay, because if you have y label and if I got the projection, so let's say the projection of y onto this feature space, it will be a linear combinations of these two features. Is that fine?
Yes, sir.
So f1 I'm writing in this fashion: x11, x21, x31, and like this, and times the alpha star. Alpha is what? Some weightage, right? Or uh, and that's
So,
how I get,
so we have taken only F1 and F2 here.
because we have only two features, no? Because x1 is of two dimensions.
Yeah.
So it is like, let's say it is weight of first person. This is, let's say, height of first person, and like that. So how many features I am having? Sorry, how many features I am having? Two features. What
Two
are those
features.
features? F1, F2. What is the dimension of each feature here?
2 cross 1.
Three. Feature dimension.
Dimension is 3. X11, X21, X21.
Is that okay?
Yes, sir.
At least no confusion
The
here, right?
feature dimension is 3, whereas the data points
Yeah,
dimension is only 2.
two.
Right.
Correct, na? Now
Mm-hmm.
that is clear in your minds.
Yes, sir, clear.
Okay.
Yes.
So we were here, right? Can you just tell me uh, the dot product of these two?
Sir, this alpha 1 F1 plus alpha 2 F2 is Y.
That should be the, actually it's not y
It is a projection.
of y. So basically it should be like coming as like this, x transpose w. I wanted to show that part, but how it will come. All right, that is my, that is what we wanted to know, right? We'll leave it that at this point, but you know that this is a projection of y.
Okay.
Y on
Okay,
F1 and F2.
feature space, not f1 f2. Basically it
Yeah,
is a,
on the features because perpendicular projection will be there.
it is a span of f1 and f2. Is that okay?
Yeah, yeah.
What will be the dot product here? Yes,
Alpha 1 star
1
X1.
star
Yeah,
plus x12 alpha
alpha
2
star, alpha 2 star.
x21 alpha 1 star plus x22 alpha 2 star, right? This is x31 alpha 1 star plus x32 alpha 2 star. Is that fine?
Yeah,
Now if you see the analogy here, it's w1 x11 plus w2 x12. Is it coming like that? Okay.
pardon, W1 X
Was that like this?
previous one. Yeah,
I was saying that y1 is a some linear combination of x1,
W1 X.
right? We didn't know that. I just found out this part. But is it basically the same as that of the previous one? So that
Yeah,
alpha star is,
basically looking like same.
no, it looks like same as of now, but it is not equal to y, right? Correct. What is not, why it is not look like it is equal to y? There is some
Big,
discount here.
It's a
yeah,
projection. This is a projection. It's not
this
a
is a
one.
projection. Yeah,
It's only the projection part.
yeah.
Now I need to add this part also, this error part. Okay, but
Mm-hmm.
let us think about this. So can I say that this is the projection, let's say p, this p vector, and I have one vector as y vector. Okay, I just write it down properly. So this is, let's say, p vector, this y vector, and there is some projection vector, sorry,
Yeah, proxy. Perpendicular part is left out.
what is this perpendicular part?
What's the error, sir?
Error.
Let's say what the error is there.
Y minus this one.
Y minus P, whatever.
Y minus projection.
Yeah, but if I wanted to get a dot product of this uh, with P, what it will be?
Y minus that projection into the projection.
Okay, okay. So in other words, actually, if I take a dot product, right, that value actually will come out to be 0, right?
Because it is perpendicular, so it will be
There, no?
W tilde perpendicular, right?
So this part is actually is not equal to Y.
Just one observation. I think there are two systems used
Yeah,
for
yeah,
moving parallelly, and there is this echo coming. So it's okay. Yeah.
Yeah, echo is coming.
Okay, continue. So let us not.
Okay, no problem.
Yeah, please continue.
Understand.
Is it better now?
Now it's
Yeah, it is
Yes.
better. No
Yes,
problem.
definitely.
Yeah.
So what I was saying is this exactly whatever we are found out is not exactly equal to your Y, right? Because some error part is missing out there, correct? Uh, if I add this with E, I'll get Y, correct, na? And
Yeah.
previously our assumption was this, like if I found out some W1, W2 such that if I get a dot
Actual
product of this with this, I should be able to get the actual label.
actual level, yes.
So in this case, now at least if you are able to understand this part, if it is fine, I'll share the screen here, uh, and I'll show the notes. Right.
Yes.
So I think the doubt was that why, how can I substitute this W star with alpha star?
Yeah, this was the doubt. Yeah.
And what we have said is this error vector W minus X transpose alpha star, because basically if you think about this, right, is it not X transpose alpha star? Okay, let us again see once more. What should I call it? This part. What is this vector?
This is X vector.
Transpose. X transpose.
This
No?
X transpose vector.
So
X transpose.
correct. Are you able to find you are fine
Yeah.
with that? Because
Yes,
it's
N by D. X is D by N. So N by D
Yeah.
means transpose.
correct. Na? So this is it X transpose. What is this alpha star?
Yes, sir.
So this is actually giving me X transpose alpha star, right? So what I'm saying is this projection is X transpose alpha star. This is my label Y, and there is some error vector here. And what will be the value of this error vector? Basically, it
Y
is
minus
Y
X
minus
transpose.
transpose alpha
Yeah.
Y
star.
minus X transpose alpha star.
So what does it? Another meaning of it? This error vector is perpendicular to this.
Yeah.
So let us say this is E, and this I'm saying this as P. So can I say that P transpose E equal to 0?
Yeah.
Yes.
Then
Or-
what
or-
is your
or-
Y? Y is basically P plus E.
Yeah.
P plus E,
Yeah.
right? No. If it is fine, then can I say that this P transpose is equal to 0 in other like what is the meaning of it? Or maybe I'll say that E transpose P. Both way it's fine, right? Because it's dot
Yes,
product is
sir. Yes,
commutative.
yes. Yeah, yeah.
So E is what? Y minus X transpose alpha star transpose. What is P? X transpose alpha star, and that should be equal to 0.
Yes, sir.
So if I open this bracket out, what should I get it? It will be Y transpose X
X
transpose
transpose alpha star
here
minus X
minus
X
X.
X transpose of transpose.
So it will be okay.
X alpha.
Can I say that it is again? Okay, let me do one thing. I'll do that
It will
alpha
be
star transpose.
alpha star transpose, X transpose transpose.
X transpose of transpose means X basically.
X.
X.
And it's
X.
already your X transpose, and
Alpha star.
here alpha star. Is
Alpha
that
star.
fine?
Yes, sir.
And that should be equal to 0. And if I do like this will be like this, right?
Yeah.
Or you can keep it as it is, but basically it is fine. What we are saying that this alpha star is nothing but whatever we have got, this should be equal to my W star. Why? Because here also I was getting say W1 X11 plus W2 X12, and here I am also getting that X11 alpha 1 star plus, like, this is also a linear combination, right? We have started with this part
Yeah,
that,
both are
why,
linear combination.
yeah, that why my label, actual label, is a
But
linear
the
combination.
value of W1 and W2 and alpha 1 and alpha 2 star are
Yeah,
different.
are
Equation
different,
is say, yeah, only value is different.
correct.
Equation
But
is the same.
but
Right now, am I understanding?
what is the W star value you have found out previously from calculus?
X transpose
X transpose
Pseudo inverse.
pseudo inverse
pseudo inverse
XY.
XY.
So the question is, can alpha star be equal to W star? Right?
Yeah.
I wanted to check this hypothesis.
Yeah.
Okay. Can alpha
Yeah.
star be equal to W star? So
Yeah.
how should I check this hypothesis?
It is
Substitute
if it
the
is
substitute the value of this value to the above equation, and if I get the left hand side equal to right hand side, then that is true, right?
Yes.
Pardon. We will put the value of right RHS, no?
See, this is the equation I got, right?
Yeah.
So now let's say I'm saying that alpha star is equal to W star,
Yeah.
because uh, uh,
This
y
is
is,
hypothesis. This is hypothesis.
yeah, but how to check that whether I'm correct or not?
Yeah.
I know this W star is equal to XX transpose inverse pseudo
Yeah.
inverse XY. Can I
Yeah.
now I'll substitute this, and if I be able to satisfy this equation, then that means alpha star is equal to W star. Okay. Now I'll
Yeah.
substitute this value in here. So what I'll get? Y transpose X transpose. What is alpha star?
X
XX transpose pseudo inverse XY.
pseudo inverse XY
XY
minus
minus. Uh,
X transpose pseudo inverse.
okay, I'll do one thing. I'll just keep it here. I'll just minus sign. I'll write it down here, right? So it will be XX transpose pseudo inverse or
Transpose of this.
XY of transpose. Is that okay?
Pseudo inverse. Where is the pseudo inverse now?
Sorry, this is pseudo inverse.
Pseudo inverse it will be, no?
Keep it like, let's say, minus.
Yeah, inverse. Write the inverse, right?
And
And
alpha star
transpose of
is
this alpha star
transpose.
again SS.
Okay.
Right. It is okay.
Let us try to expand the second quantity. What it will be then? It will be X transpose, Y transpose, XX transpose, inverse transpose, suppose, right? Is that okay? Is that fine?
Yeah, it is okay. This one is a scalar quantity.
Which one?
Okay. No, it is
Now
okay.
what are the dimensions?
No, it is okay.
Let us say I'll do like this, and then
And
X transpose XY. Okay. Okay. What about this part? So basically it is A transpose A.
I.
Yeah, it will be I.
I, or it will be I? I think not about this, right? I think this is going to be I, right?
Yes, sir. That will be I. Yes.
Huh? Correct, no? Okay.
Yes, sir.
I think, okay. Let me write it down. So this is XX. This you understood, right? This is X transpose, Y transpose, XX transpose inverse transpose. Then I'll have XX transpose.
XX transpose will be A means then A inverse will be I only, no?
Huh?
If we take A,
correct. So this quantity will be I, right?
I. Oh, okay.
Then what I'll have here?
I think
I'll
the
have
first term it should be Y transpose X transpose.
Yes, sir. It should be Y
right.
transpose, X
Sorry,
transpose.
correct.
Yeah.
It is Y
Yeah,
transpose X
yeah, Y
transpose.
And I was thinking
transpose.
there's something wrong.
So now this is I. So I'll remain with I Y transpose X X transpose pseudo inverse transpose XY, and that is exactly equal to this term, this and this.
Yeah.
So this minus this will be equal to 0, right? So that means if I substitute the solution for W,
This transpose of universe, transpose of X transpose universe is the same, right?
huh?
So, but the dilemma is, sir, X alpha star is a linear combination in R3,
Correct,
and W star is a linear combination in R2.
right?
How
So
can they be the same?
okay, so the thing is, no, they are not same. What the conclusion is that X transpose W star is the projection of labels onto the subspace spanned by the features. Okay, so let us say you're saying that W is in
Alpha is also in R2,
R2,
no,
right? Yeah,
Preeti?
correct.
Alpha, no, alpha is an R3 because it's
Why?
Rn, right? Number of data points, no?
No, alpha is
We are scaling with the feature vector only, no? Alpha 1, F1.
this
Yeah,
true.
yeah. Alpha is also R2.
But F1 is an R3, no?
That is okay. If let it be no F1 F2 in R3, but what about alpha is a constant, right?
Alpha is a constant
Okay.
in R2. This is
Okay.
our R2.
No, just a minute. Alpha is what are you thinking? Alpha you are thinking as vector or like individual quantity you are thinking?
It's a scalar only. It's a because it's a
Okay, what is this?
no. Sorry. Wait.
L,
What am I saying? Sorry. It's uh, okay. It's a linear combination of
of
that. Then it is a
2 dimensions. Let F1 be in 3 dimensions.
yeah. It's a collection of alphas. Correct. Alpha star is nothing but a
So
collection of alphas.
yeah,
Correct.
I'll write it down. So let us say alpha 1 F1 plus alpha 2 F2. It's a
Alpha is the vector found by the scalars. Am I right?
linear combination of features. Okay, and W1 x11 plus w2 x22 or x12, like that. It's a linear combination of what is it, the data points, let's say.
Data points.
Okay, I'll write down both the figures here. So here f1 f2 is here, right? F1 f2. Okay, and this is this is like this is
Alpha
alpha 1
1,
f1
F1.
f1 plus alpha 2 f2. Okay, right?
Yeah.
But basically
Yes.
it is coming as like alpha x transpose alpha star, because alpha star is, we are saying that it is alpha 1 alpha 2, it is a 2 dimensional vector, right? Okay, is that fine?
Yes.
This is your feature vector. And what about w? How does w will look like? So basically you have x1, you have x2, you have x3, right? Is that fine? But each of x1 x2 x3 is having 2 components, right? And what is where is your w vector?
In the space.
Some vector w, right? But this w vector is like you are taking a dot product of w with each of this. So w with x1, w with x2, and w with x3.
Yeah, W is in the span of x1, x2, x3. Right?
Right. So w is in a span of, let's say, data points, right? It should be a
Data.
2 dimensional vector.
W is the projection of Y.
W is a
Projection, is it the
no
projection of Y?
no.
No.
W
Inner
cannot be the
projection.
projection of the y, no.
That is different case. This is different case.
X
W is
transpose
not
w, X transpose w is a projection of y. See, w is a vector, no. W is a vector.
Okay. We are scaling W so that we will get
The projection.
W is such a vector which can be written in the form of x1, x2, x2, x3, linear combination of because W is in the span of x1, x2, x3. Am I right? And each
okay.
data point is having two features, two dimensions.
So projection is basically is a scalar quantity, right?
Yeah, projection is a scalar quantity.
So if that projection is there, the projection vector is a vector. But if I just wanted to find out the projection, that is always a scalar quantity.
Only a scalar
Correct,
quantity.
sir. Correct.
So you cannot say
Right.
W as a projection because, or you cannot say it as a vector also, projection vector also, because then it is not a vector basically. Projection vector is this x transpose alpha star is a projection vector, but I can say now x transpose W also a projection of the labels. Why? Because it is satisfying this equation. So now x is also in sorry, W is in 2 dimensions, alpha is in 2 dimensions. Is that okay?
Okay.
But the spaces are different. So W is in different space and alpha is in different space. I hope that is okay. You just
Yeah.
Thank you, sir.
Got
Thank
it.
you so much.
It's good one. Good one.
so you can yourself. I think it is, if it is not
Yeah,
clear
yeah.
for you as well.
Now it is okay. We
What you
will.
can, yeah, what you can do is maybe you can go back and you just try to project all these things by your own. I think then you'll
Okay.
be able to.
No, it will be clear now. Now it is.
Okay. Fine. I'll upload that on the discourse, that this PDF with discourse,
Okay, sir.
as well
Thank you
as
so much. Thank you so
Okay, sir. Thank you, sir. Thank you.
thank you.
Revision. Let us go to the revision session. Okay. Thank you.
So for revision session, the link was same, right?
Yeah, I think yes.
So we have revision session also today.
No, it is not instructor